everyone. I hope you're having a good time at HashiConf Digital. Welcome to the Consul Product Roadmap Talk. I'm Preetha Appan and I lead engineering for the Consul team at HashiConf. With me co-presenting is Neena Pemmaraju, who leads product. We have some exciting news to share with you today, but it's top secret, so don't tell anybody at HashiConf. The two of us have a total secret identity. We are also co-founders and CTOs of a startup called StarNav. StarNav was founded by us with a very ambitious mission. We want to enable anyone to drive an ATV anywhere in the universe. Here's the overall vision that we were thinking about when we founded StarNav. We got a bunch of funding and we have deployed ATVs both in planet Earth and in other planets around the universe. We are creating a remote driving marketplace. We want to expand to multiple locations over time, and we want it to be free for students and for nonprofits. Like any other startup, we began by first launching our first set of products. We started with a monolithic architecture. We had our StarNav database that contained all our vehicle locations and information, a monolithic application, which is the StarNav server that contained all of our business logic, and then, of course, we had our website through which we allowed our users, our drivers, to interact with these vehicles and drive them remotely. As we started getting our first orders, we decided to split our monolith into microservices because it was already getting too complicated. So our first set of microservices were an order service, a tracking service, and a billing service. This introduced our first set of networking challenges. We want to be able to incrementally migrate from a monolith to microservices because we had a small but growing user base. We want to be able to route traffic only to healthy instances of these microservices as they come up and down. And thirdly, we wanted a simple and easy zero-touch way to integrate with third-party applications like Google Analytics and other things that needed to interact with our microservices. We discovered Consul. Consul provides service discovery and DNS capabilities out of the box. Service discovery is a key building block for transitioning from monoliths to microservices. And with Consul DNS, we get zero-touch integration with other tools as our complexity grows. Consul also provides health checks natively. So this gives us the ability to track the health of the various instances of our microservices and make sure that we only route to healthy instances. We also discovered Consul Template, which is a very versatile tool to integrate Consul with other systems and tooling that we already had in place. And we used it initially to configure our software load balancers and our very simple CI/CD system when we wanted to track changes to these microservices. This was how our architecture looked like once we introduced Consul. As you can see here, we have our front-end website, we have the drive.mars.com, and then we have the Mars driver mobile app. And then we use Consul DNS to address the instances of our order service and our billing service, which are our initial microservices. Consul monitors these microservices and maintains them in its catalog. And then we also have a primary database and a failover or a secondary database, and both of those are also monitored and tracked in Consul. By leveraging Consul for service discovery, we achieved the following outcomes. We were able to introduce microservices incrementally and adopted service discovery as a pattern, which would stay with us over time as we grew our product and complexity. And then we also leveraged Consul DNS to use as a very simple, naive round-robin load balancer. And other third-party apps could easily reach our microservices that were registered in Consul through Consul DNS. At this point, we continued to be successful at StarNav, and we had to start scaling for traffic growth because we started getting more and more users and orders. In this phase of the company, we also had other changes that were happening. So we launched a new remote driving marketplace. The number of vehicle rentals we had grew by 5x, which is a great sign of success. And we discovered the need for more than just a round-robin load balancer that Consul was providing us. So we decided to go look for a custom load balancer and a firewall which would meet our needs as we grew. So as a reminder, this was what our architecture looked like when we introduced Consul with just Consul Service Discovery and Consul DNS and a few microservices. And this is what our architecture looked like once we switched to adding a load balancer. This load balancer now sits between our front end or our users and our order service, because the order service is the one that was experiencing a lot of traffic and a lot of growth and needed custom load balancing capabilities. Meanwhile, the company also continued to grow from an organizational perspective, so we had more teams and more specialized roles. So we have our engineers or developers, and then we have our infrastructure and SRE, DevOps specialized roles, and then we had networking specialists as well as security specialists in the org. After we introduced the custom load balancer to update, to track instances of the order service, this is what our typical developer workflow looked like. So here's our developer D, and so when she wants to scale the order service or migrate workloads to other new services, she needs to submit a ticket to the infra and SRE team to get a new server provisioned, and then they do some work, and then they submit a ticket to the networking team to get a server added to the load balancer. And then after that, there's another ticket submitted to the security team to get it added to the firewall. This introduced an entirely new set of challenges to us. So the first thing is that there's a very manual workflow that slows down overall application delivery velocity because of waiting for this ticket-driven workflow in order to get changes provisioned and keeping the load balancer up to date as these microservices come up and go. There's also a lack of standardization in terms of how these load balancers are created and maintained, and due to that, it introduced increased risk from manual processes. At this point, we learned about Consul Terraform Sync. And Consul Terraform Sync is basically a very cool network automation workflow tool that combines the power of Terraform and Consul. You might have heard in the Terraform keynote already, but Terraform is an infrastructure as code and enables you to describe all sorts of devices and infrastructure. And so we were able to use Terraform to create modules for these custom load balancers and firewalls. And Consul Terraform Sync basically monitors changes in Consul as these services come up and down, and updates and uses the Terraform module to update the load balancer automatically. This is what our architecture looked like prior to introducing Consul Terraform Sync. As you can see here, we just have the load balancer and the manual ticket-driven workflow whenever we want to update this load balancer. And then this is what our architecture looked like after we introduced Consul Terraform Sync. So as you can see in this diagram, Consul Terraform Sync sits between your load balancer and the order service. It's checking and monitoring the Consul catalog. Anytime there's an unhealthy instance of order service, it gets automatically removed from the load balancer. And then when the healthy instance comes back online, it gets automatically added to the load balancer. So at this point in time, with this stage of the organization that we're in, we adopted Consul Terraform Sync, and through that, we also adopted infrastructure as code, because now we've introduced Terraform to maintain all of this load balancing infrastructure. We no longer have any manual workflows or tickets. It's all automated through Consul Terraform Sync. If you want to learn more about Consul Terraform Sync, I recommend watching senior Consul engineers talk, Kim and Melissa. They're giving a talk about Consul Terraform Sync later in this event. The next phase that we entered at this point in time was continuing to grow our product and organizational complexity. It's often a sign of success, as we grow our user base, there's more demands, there's more requests for new features and so on. So we entered a whole new phase of growth here. From a product perspective, we introduced a lot more new features. Now we have remote races. So previously we were only mapping drivers, or people were only driving one vehicles individually, and now we had the capability to race against your friends or race against groups of people, and then companies wanted to sponsor these races, and then the product itself became complex and became a platform so that other people could integrate with it. And then we also discovered and started using containers and runtime platforms like Kubernetes. So lots of changes happening in the company and the product. This introduced a whole new set of challenges. We now have many autonomous engineering teams. Each engineering team picks the right container platform and cloud that makes sense for them. So we had a proliferation of containers, Kubernetes, and different managed services like AKS and EKS and GKE. And we also realized that even though we did introduce a centralized load balancer and firewall for the one large microservice, the order service, it doesn't really scale when we have many, many more microservices being added all the time. This is when we discovered Consul Service Mesh. There are three main pillars of what a service mesh can provide for us. So the first thing is security. It enables both authorization and authentication and secure communication across microservices. Consul also has a rich intention and access control layer, which allow you to describe and model which service is allowed to talk to which other service and endpoint as well. Moreover, it also enables us to improve our observability, so you can collect and visualize metrics to understand service-to-service communication. And thirdly, it also has traffic management capabilities. So as we have these new teams and new platforms and things are being brought up and down and new versions are being deployed, it allows us to do that in a safe and controlled way through models like canary deployments and blue-green deployments. So again, as a reminder, this is what our architecture looked like when we introduced Consul just for service discovery and Consul Terraform Sync. We had a couple of microservices. We have our Consul Terraform Sync, updating our load balancer when order service comes up and goes down. And this is how it was changed when we introduced Consul Service Mesh. So as you can see here on the right, we now have more microservices. We have a ride streaming service, and then we have a terrain mapper. We have another backend database, the terrain database. These ride streaming services and terrain mapper are both running in Kubernetes, and they're communicating with each other in a secure way through Consul Service Mesh, which basically deploys and manages Envoy as a proxy for you in front of these applications. And then the communication between these microservices and the database is also done in a secure way through the service mesh. As we expanded our product's capabilities, there was a need for the order service to start communicating with the ride streaming service in order to process ride streaming orders. However, the team that was responsible for the order service wasn't quite ready to migrate to Consul Service Mesh. But that's okay, because we can enable an incremental migration pattern through another Consul feature called the Ingress Gateway. An Ingress Gateway can be used in order for services that are outside the mesh to communicate with services that are within the mesh. So in this example, all communication between the order service and the ride streaming service goes through the Consul Ingress Gateway. Similarly, as we grew our product complexity and added more applications, we had to communicate with the ads API from the terrain mapper. And this was a third-party API. And so in order to enable that communication, that goes through a terminating gateway. So the terminating gateway could be used to enable communication between services that are within the mesh to services that are outside the mesh. And so that's what you can see there on the bottom right. Apart from these features and being able to migrate incrementally, the Consul UI also has a really nice topology view. So it shows you service-to-service communication in a very visual way, as seen in this example, with the order service talking to the terrain mapper, which then talks to the ride streaming service. And then it also shows you all these metrics like requests per second and error rates and so on. So it gives you a very quick visual overview of what's going on with the service mesh. So at this stage of our organization, we've now adopted Consul Service Discovery, Consul Terraform Sync, and Consul Service Mesh. The outcomes that we were able to achieve with Consul Service Mesh is securing communication between microservices, no matter which platform it's running in. We're able to observe and visualize traffic between these microservices, and we're also able to do incremental rollouts and traffic failover and path-based routing. I'm now going to hand off to Neena who will talk you through further stages of StarNav.
Thank you, Preetha. You heard from her about the growth of StarNav. Today I want to talk about what happens next in the growth of this company. So StarNav continues to be a really popular app, and we now have customers worldwide that are interested in our services. So far we've been running everything out of our North American data center, but in order to provide really good services to our worldwide customers, and also to comply with local laws, we need to set up services in local geographies. And along with that service in the local area, we need to then add ability to do disaster recovery and failover between these different data centers. So this is where we find ourselves in a really good position with having selected Consul, since Consul natively supports multiple data centers via the federation feature, with one data center being the primary and others as secondary. And then the administrations of all these data centers is simplified, as ACL tokens can be replicated across the data centers. Consul also then provides mesh gateways for service-to-service communication, as well as any control traffic that needs to go between the data centers. And the Consul network area enterprise feature supports communication in a hub and spoke technology, thus reducing the cost of communication between data centers. I wanted to also flag that yesterday Stripe presented their use case of Consul. I would recommend watching that to learn more about how they are using Consul across multiple data centers. So now that we are adopting these new technology, just as a recap, here's our existing single data center architecture. And then once we have the same thing deployed across multiple data centers, you can see the two Consul data centers in two different regions in Amazon, and then a mesh gateway connecting these two to each other, so that you have services from our one data center being able to talk to services in a different data center. And the outcome of now deploying Consul across these multiple data centers is we basically have a service running worldwide in different clouds, and then we also providing all the service mesh capabilities, as well as failover for services in these different clouds. So that's a really exciting phase. The company continues to grow. We are expecting now to get even more broader and diversify through partnerships and acquisitions. So we need to onboard new partners, and some of them have really exciting technologies, so we are proposing acquiring some of them. What this does is our platform now needs to be used by our partners, and since they will offer their products on top of our platform. And in order to do this, though, we need to open up our platform to the partners. And then because of potential acquisitions, we anticipate now that we will have multiple independent Kubernetes clusters that are managed by different teams. We'll also have cases where the teams that are using the services may not always want to run their own service and would want something like a managed service that Consul provides. As well as teams running in different runtimes like Kubernetes and ECS, etc. So this presents its own set of challenges. And luckily, there are some things coming in Consul that we are thinking of using. The first is the API gateway, which exposes the mesh services to services outside of the mesh using the Kubernetes Gateway API. This is not yet available, but we'll be doing a tech preview launch of it in November. So I would ask to please watch out for this. The second thing is multi-tenancy, by letting independent teams manage their own Kubernetes cluster, but have a single service mesh connecting all of them. So there's a recorded talk on this at HashiConf. So please make a note and watch it to get more details about this admin partitions feature. And then finally, Consul Service Mesh is running on ECS. So again, there's a lightning talk coming up on this. Please watch it. This is available in beta already. So just to recap, this is our current multi-DC architecture in two different regions. And then the first thing we will do as we anticipate this diversification that we are going through is we'll add the API gateway. So you can see that we've added an API gateway to expose the /rides and the /map endpoints to our partners. Notice that we haven't added the API gateway to the internal network yet. This is something we will consider in the future, but the first goal was to add it such that our partners could access our platform. And then as we are looking at all these acquisitions, we will also look at the admin partitions enterprise features as the need for independent Kubernetes clusters continues to increase. And so with the modifications we are thinking to our architecture, we are going to achieve some of the things we set out to achieve. First, with the addition of API gateways, we can now open up our APIs to partners outside the organization. And then once we deploy the admin partitions enterprise feature, Consul can be run as a shared service across the entire organization while letting independent groups manage their Kubernetes clusters themselves. So that's all for StarNav. I hope you liked our journey. However, as Preetha said, this was really a fake role for us. I want to switch back to our current roles at HashiCorp and talk about some of the things we are exploring to do in the future. So back to our old roles, or our actually really exciting roles at HashiCorp. And let me talk about some of the things we are thinking of in the near future. So today, Consul is available as the HashiCorp Consul service in Azure. It's a marketplace app. And then it's also available as HCP Consul on the HashiCorp Cloud Platform on AWS. So first, one of the things we are thinking of doing here in the future, we want to expand HCP Consul to be available in other popular clouds as well. We are also exploring mesh federation, where each mesh is independent, as opposed to the current model where the primary manages the whole mesh from an admin perspective. Once we do mesh federation, then it becomes a building block for us to support service-to-service communication between self-managed and HCP Consul. And then finally, we are looking at ways to simplify the deployment by reducing the need for client agents running on every node in your infrastructure. So in summary, when you look at Consul, what we provide is comprehensive multi-cloud service networking with identity-based security, observability, and resilience for all application traffic across multiple platforms and cloud runtimes. We also provide networking automation using Consul Terraform Sync to automate networking infrastructure. And then finally, while you can definitely run and manage Consul yourself, we have the managed version of Consul available via HCP Consul and HCS. If you'd like to learn more about Consul, check out the resources at consul.io and on HashiCorp Learn. And then on behalf of Preetha and me, I'd like to thank you for joining us today at HashiConf.